Question 1 is giving us this equation to start with right here. Y squared minus x cubed equals 22. And what they want us to do is they want us to find dy dx. So that's just the derivative like we've seen on a lot of earlier problems. The only difference between this problem and those earlier problems is instead of having a nice clean equation that was like y equals 3x squared minus 7x where the y's were on one side and the x's were on the other, what you're going to see in these equations going through this quiz is x's and y's are mixing together and there's no way to separate it back out into this nice clean equation. However, they still want out of us the derivative, the dy dx. And so that's where we move into this new process called implicit differentiation, which is why they use that language there, differentiate implicitly. It's just describing a new process. How this process works is you take the equation that they've given you, you wrap it in a set of parentheses, and we're going to dx this equation. So we're going to be taking the derivative of each one of these pieces with respect to x. And my little saying that I use when I'm doing this process is every time I take a derivative, I get extra shit. And what that extra shit looks like is envision there being this little box behind that d up on top right there. And what you're going to do is every time you take a derivative, you're going to get this extra piece that's going to say d, and then you'll fill that box in with whatever the letter is you took the derivative of over dx. So what that looks like is we start here with the y squared. The derivative of y squared would have just been 2y. I took the derivative of a y though, so I'm going to get a dy dx. So I filled that little box in on top with a y value right there. Done with that piece, go on to the next. The derivative of x cubed here, using our power rule, bring that 3 down, we'd get 3x squared. And then this time, took the derivative of an x, so I get a dx dx. Filling that box in with an x because I took the derivative of an x. Equals the derivative of a constant, no matter what method you're using, is always 0. At this point, I then do what I call a cleanup step. On these earlier ones, there's not a lot to do, but it's still worth doing. We get 2y dy dx, nothing happened there, and then we get minus 3x squared, and dx over dx cancels out. It's really like having 5 divided by 5. The 5s cancel each other out, and you're really looking at a 1 right there. So the dx's cancel each other out, and that's all still set equal to 0. So remember that what we're trying to do on this is get dy dx. We're trying to find that. So we just treat dy dx like any other variable right here and solve for it, meaning get it alone on one side of the equals. So I'm going to start by moving the 3x squared over to the other side. So I add 3x squared. That's going to get me 2y dy dx equals 3x squared. Since all these things are being multiplied on the left side here, I can just go ahead and divide both sides by 2y. And I get out of there that dy dx equals 3x squared over 2y. So that's the first part of our problem. That's the first part of our answer. That is what our derivative actually equals. That is our dy dx. Then the second part here wants us to find the slope of the graph at the given point. So the given point is that 3, negative 7. And so what we're doing is taking that 3, negative 7, that's an x and that's a y, and we're just going to plug them into our derivative here. So notationally you would say dy dx evaluated at 3 comma negative 7, and so that's going to equal 3 times, and our x value is 3 squared over 2, and then our y value is negative 7, and then we'll just go ahead and plug that into our calculator. So we go to a calculator. If you've got one of the newer calculators, not just a color one, but a newer one, and you can hit this, not second, but if you want to hit alpha and then y equals, you'll see number 1 in that menu is the numerator denominator. Hit enter on that, and that'll split that up into a fraction for you. And so you can just type that in exactly how it looks right there. So 3 divided by 3 squared, and then over 2 parentheses negative 7. We go ahead and hit enter on that. And the nice thing about doing it that way is you can see it gives us a fractional answer out. So negative 27 over 14. And what you'll notice on these is they talk to you specifically about an integer or a simplified fraction, which means they don't want decimals. But let's talk about how to enter it if we don't have that fancy button. Really what you want to do is say to yourself, it's always the whole top in a set of parentheses divided by the whole bottom in a set of parentheses. So If I don't have that special button, I would hit a parentheses to start it, and then I would type in that first piece. So 3 times 3 squared, close that, divided by, open for the bottom, 2, plug in that -7, close it, and then close for the whole bottom there, and hit enter. Here it gives us a decimal, but like we talked about, we know we need a fraction out for the answer. And so that's when you're going to go ahead and just hit this math and then number 1 frac right there, hit enter on that option. And you'll see it puts answer. It's going to grab that answer and turn it into a fraction for us if it can. And sure enough, it did. It turned it into that same fraction, that -27/14. And so that's the second part of the answer on this problem.